right, hello sophomores. This is Mr. Allen. I'm going to help you out with a couple of the tougher problems from a few of your trig worksheets. So one thing we want to keep in mind, this whole set of worksheets is kind of like the log unit, where really we're not doing a bunch of crazy stuff. We're just manipulating the numbers. Okay, so we're not really changing the value of these things. We're just replacing them with things that they're equal to. Kind of like in the log unit, instead of 9, we might use 3 squared. Okay, well here, instead of secant theta, we might use 1 over cosine theta. So it's just a lot of substitution. We just need to know what we're substituting in. We'll look at a few hints. But also keep in mind, sometimes we don't know exactly what direction we want to go, and maybe we just need to try something and see if it works. So we'll take a look at a couple problems, starting with, from worksheet number 1, problem number 28. We got secant 12 degrees times the square root of 1 minus sine squared of 12 degrees. All right, now on a problem like this, what are some things we notice that maybe is not in every problem, other than the radical, of course? The 1. Whenever you see a 1 in there, well, that's probably a hint that you're most likely going to be using one of these bottom 3 identities here. Okay, now it doesn't have to be this identity exactly. For example, if I have a 1, well, I can replace it with sine squared theta plus cosine squared theta, or this stuff, or this other stuff, if we solve for 1. Okay, because again, you might be thinking, well, this isn't solved for 1. Well, that's okay. I can subtract tangent squared theta over, and then I have 1 equals something. So we can manipulate the stuff a little bit, but anytime we see a 1, we're maybe going to be using these things, or at least a version of those things. Okay, so let's see. We got secant 12 degrees times the square root of 1 minus sine squared of 12 degrees. So along with the 1, well, which other of these identities has sine squared in it? Okay, so if we look at these, well, the one on the left here. Okay, so I've got a 1 and I've got a sine squared. Now, can I make this look a little bit nicer? Because here, what do we have exactly? We have 1 minus sine squared theta. I'm sorry, sine squared of 12 degrees. Can I get this to look like 1 minus sine squared of my angle? Well, sure, if I just subtract sine squared of my angle over, then I'd have cosine squared of my angle equals 1 minus sine squared of my angle. So then this whole thing here could just be replaced with cosine squared of my angle, which in this case is 12 degrees. Okay, so we'll start with that. So the secant 12 degrees, we'll leave that alone for now. And then I've got times the square root of, and again, we're going to replace this thing with cosine squared of 12. Okay, all right, so that's a good first step. Next, let's again leave the secant squared alone for a minute. Sorry, not squared, just secant of 12 degrees. And then, well, if I've got the square root of something squared, so the square root of cosine squared of 12 degrees, it's just the cosine of 12 degrees. So times the cosine of 12 degrees. Okay, so that's a little bit nicer. Now we got rid of that radical and an exponent. And then can I simplify this any further? Well, we've got secant of an angle. What is secant? What can I replace secant with? If we look down here, well, secant is the same as 1 over the cosine of my angle. So then let's do that. Let's replace secant of 12 degrees with 1 over cosine of 12 degrees. And then I got that times cosine of 12 degrees. And then we can think of this, sorry, that got off center there a little bit. We can think of this as cosine 12 degrees over 1. Anyways, I'm going to end up with cosine of 12 over the cosine of 12, which these are both going to reduce to 1, and I just end up with 1 for my answer. Okay, so then this big scary looking thing that we started with simplifies to just 1. Okay, so again, it's just a bunch of substitution and a little bit of manipulation here. We just got to, identify, okay, what do we want to substitute in and what are we going to use? Okay. Anyways, there's number 28 from worksheet number 1. Let's move on next. And I'll try to keep it centered on the camera here. Sorry if I wasn't before. Worksheet number 2, number 14 from that worksheet. All right, so this one, we don't just have our sine, cosine, and tangent that we're used to. We got cosecant, cotangent, and secant, and minus 1 down here as well, and a fraction. So this one kind of scary looking, but then let's see, how can we work with this one? Okay, now, like we were saying, we have all the cosecant, cotangent, secant. I don't like that stuff. I'd rather have sine, cosine, and tangent. So maybe we can try putting everything in terms of sine, cosine, and tangent. Okay. Also, on a problem like this, I mean, yeah, I got a minus 1 here, so I'm probably going to be using one of these bottom three identities at some point, okay, most likely. But sometimes it's hard to tell which direction we need to go. So just try something, see if it works. Okay, if not, maybe you got to start over, and that would be too bad, but let's just try something and see if it works. So let's see, I don't really like having cosecant in there. So instead of cosecant, I'm going to replace this with what it equals, which is 1 over sine. So then I get 1 over sine theta. Minus, I don't really like cotangent either. Let's replace cotangent with what it equals, which is cosine theta over sine theta. And then over, let's deal with that later. We'll go ahead and leave it as secant theta minus 1 for now. Okay. All right. So on the top here, I got 1 over sine theta minus cosine theta over sine theta. Well, these have a common denominator of sine theta, so then I can combine those two things. And then that's going to give me 1 minus cosine theta over sine theta. Okay, so then that's my numerator, divided by, and then we got the secant theta minus 1. Okay, and then what can I replace the secant theta minus 1 with? Okay, so if we look at our identities, then we'll see I can replace secant theta with 1 over cosine theta. So just this part right here, I'm going to replace that with 1 over cosine theta. Okay, and then we got minus 1. Now let's see, if I'm subtracting two things, I'd like to have a common denominator. So then, well, how can we rewrite 1? How can we manipulate 1? Well, I can write it as, how about cosine theta over cosine theta? That way I'll have that common denominator. All right, now let's do what we did on the bottom, what we did to the top. Let's combine those two fractions. So we'll leave the top alone for a second here. We'll scoot this up. And we got the 1 minus cosine theta over sine theta on top. And then divided by, and then on the bottom, well, that's going to be 1 minus cosine theta over cosine theta. Okay, next, well, now we want to remember a pretty basic algebra rule. Dividing by anything is the same as multiplying by its reciprocal. So then dividing my top fraction by 1 minus cosine theta over cosine theta is the same as multiplying by cosine theta over 1 minus cosine theta. So in other words, we're going to turn this complex fraction, turn this division problem into a multiplication problem. So then I want to take my numerator, which is this part here, 1 minus cosine theta, need some more space down here, 1 minus cosine theta over sine theta times the reciprocal of my denominator. Okay, so it's going to be cosine theta on top over 1 minus cosine theta on bottom. Okay, all right, next, since I'm multiplying two fractions, I can basically treat this like one big fraction. I got these two things on top, these two things on bottom. And then let's see, I got 1 minus cosine theta on top, 1 minus cosine theta on bottom. So then those are going to reduce to 1s, which we don't need to write the 1s. And we just end up with cosine theta on top over sine theta on bottom. Okay, and then is that my answer? Well, maybe, but if we look at our trig identities here, there we are. Cosine theta over sine theta is just cotangent of theta. So then we can simplify this to cotangent theta, and then that's our answer for number 14 from worksheet number 2. Okay, so again, that one was a little bit trickier. And also, throughout that problem, there wasn't necessarily a clear path in which direction we were headed, but just keep working through it and see what you can change, what you can get to reduce, or we like to say cancel, but technically reduce. And hopefully we end up with something a lot simpler like this. Okay. All right, we're going to do one more together here from worksheet number 3. And from worksheet number 3, we're going to do number 11, which looks kind of scary. We got a couple binomials squared with some trig stuff in there. So let's see what we can do with this. Okay, now before we worry too much about all these different identities and what we can replace stuff with, I'm not too scared by this problem yet because I just got sine and cosine. We're used to that. But we got some exponents and some other stuff we want to deal with. Now let's see, I can't combine like terms until I square these two binomials. So let's start with that. So I want to multiply out each of these binomials. So I want to FOIL this out. Now, I would recommend writing this binomial down twice and foiling it out. We're going to do a little mental math here. If I FOILed this thing out, I'd have 4 cosine theta times 4 cosine theta to start, which would be 16 cosine squared theta. Next, I want to multiply my outside term and my inside term, and I would get that term twice. So then I'd have 4 cosine theta times negative 3 sine theta, which would give me, and I get that twice. So I get negative 12 sine theta cosine theta twice. So that's going to be negative 24 sine theta cosine theta. Okay, and then next I'd have negative 3 sine theta times negative 3 sine theta, which would be plus 9 sine squared theta. Okay, hopefully we got room for this. Now we got plus, we got to square this binomial as well. So do the same thing, write it twice, FOIL it out. But I'd get 9 cosine squared theta to start. And then plus, we're going to get this times that twice. So plus, I get 12 sine theta cosine theta twice. So that equals 24 sine theta cosine theta. And then finally, squeeze it in on the edge over here. Hopefully you guys have space on your papers. 4 sine theta times 4 sine theta is going to give us plus 16 sine squared theta. I should have written a little smaller. Hopefully you guys can see that. Okay, so now I've got all this stuff multiplied out, got this big old mess here. And then, well, what can I combine or get rid of here? Let's see, the big thing in the middle, I've got the negative 24 sine theta cosine theta. And over here I've got positive 24 sine theta cosine theta. So then, well, those cancel each other out. Okay, so that's good. That's gone completely. And then now we can just combine like terms. It doesn't matter which ones we do first. We'll just start on the left. I got 16 cosine squared theta, and then I've got 9 cosine squared theta. So then how many cosine squared thetas do I have altogether? Well, 16 plus 9, we get 25 cosine squared theta. Okay, and then that takes care of those. I'm just going to cross them off because we've used them already. I'm sorry, I couldn't even see on the edge over here. And then we've got 9 sine squared theta plus 16 sine squared theta. We'll then add those together, and I get plus 25 sine squared theta. Okay, so big, long second line here. Got it down to something much simpler now. Okay, let's see. I got 25 of this thing plus 25 of that thing. Well, they both have that 25 in common. Let's go ahead and factor that out. So if we take out the 25, then I'm left with cosine squared theta plus sine squared theta. All right, and then now what can we do? Well, let's go check our trig identities again. And do we have cosine squared theta and sine squared theta anywhere on our trig identities? Yeah, down here. Now, the order doesn't matter. If I'm adding two things, I can switch the order. We have a sine squared theta plus cosine squared theta, which is what we have right here, sine squared theta plus cosine squared theta. Well, that just equals 1. So I can replace this whole big thing with just 1, and then that leaves me, sorry, it's so shaky here, with 25 times, well, just 1, and 25 times 1 is 25. So then that's my answer for number 11 from worksheet number 3. So these can be kind of scary, but look for certain things. A lot of times you want to put things in terms of sine, cosine, and tangent instead of the cosecant, cotangent, and secant. And anytime you see a 1 in your problem, you're probably going to end up using either these exact identities, or maybe you need to manipulate it a little bit. Maybe I have 1 minus cosine theta. Well, I can replace that with sine squared theta. So anyways, just keep in mind, keep this sheet handy from your notes. Keep these identities handy where you can see them. And then it's just how can you use substitution and manipulate those numbers. If you guys have any help, just ask your teachers for help.